Okay, we'll see how this goes. I'm gonna try to make some videos for you guys so you can stay caught up while we're out of school for the coronavirus. What we did last time before we left for spring break, we dealt with series. So let me put a series up here. Not a series, a sequence. Okay, so we dealt with sequences. Look like this. What is a sequence? A sequence is just a string of numbers. You got your first number, you got your second number, you got your third number, you got your fourth number, and it does that forever. Now, what we're going to start doing with is series. What's a series? A series is the same thing, except now you're going to be adding those numbers up. And so it'll be A1 plus A2 plus A3 plus A4. And we're going to do that forever. So remove the commas, put in addition. Let's look at a couple examples. Okay. What if I had a sequence of ones? What would that be? That would give me 1, then I get a 1, then I get a 1, then I get a 1. And I do that forever, that guy converges to a 1 because it never leaves 1. But what if I turn that into a series? N equals 1 to infinity of 1. What's that going to be? That's going to be 1 plus 1 plus 1 plus 1. And I'll do that forever. What's going to happen to this guy? Of course, this guy's going to blow up because if I add up 100 of them, I'm going to get 100. Now, sequences weren't very hard. They were kind of nice, but really a series is a sequence. Sorry about that. So let me show you what we mean by that. Okay. Let's look at this, guys. Define define Sn is equaling the sum n equals 1, little n equals 1 up to big N of an. So that means I'm just going to sum up the first big N terms. So that will equal a1 plus a2 plus a3 plus ... plus a big N. That's what this means. So what would that be? Let's say if we had our sequence of ones. What would S1 be? Well, S1 would just be the first term. What would S2 be? S2 would equal 1 plus 1, which would equal 2. What would S3 be? S3 would equal 1 plus 1 plus 1, which would give you 3. So what would Sn be? That would just be n. Now, what's the limit as n goes to infinity of Sn? Well, that's just going to be infinity, so it's going to blow up. Okay, so that's how you can look at a series and turn it into a sequence, which we've got a little more tools to deal with. Okay, so we're going to go next. Sorry, first video ever made. Now, let's look at some other sequences in series and see if they converge or they all diverge. Let's look at this one. So let's say we got the sum n equals 1 to infinity of 9 divided by 10 to the n. What would that give you? Okay. First, I'm going to stick in 1 for n, so it's going to give me 9 divided by 10. And then I'm going to stick in 2 for n, so it's going to be 9 divided by 10 squared plus 9 divided by 10 to the third plus 9 divided by 10 to the fourth, and I'll do that forever. What number do you think that might be? Let's look at that. What's this going to be? That's 0.9, right? And then I'm going to add to that, that's 0.09. Then add to that 0.009. Add to that, I can get 0.0009. And then I'll keep going forever. But what number do you think that'll look like? That'll be 0.9999. That's going to equal 0.9 repeating. What is 0.9 repeating? That's actually equal to 1. So this series right here actually converges. Let's look at another one and see what you think about it. about the sum n equals 1 to infinity of 1 over n cubed? That would be 1 plus, now it's 2 cubed to be 8, so it's 1/8 plus 1/27 plus 1 over 3, 4, 4 times 4 times 4 is 64, plus 1 over 5 times 5 times 5 is 125, plus 1 over 6 times 6 times 6, and cheat on that one, 216. You just keep going on forever. Now, so the first guy, you got a 1. Now if I add this one and this one, so that's S1. S2 is going to be add this one and this one, and you'll get 1.125. Now S3 is going to be add this one, and this one, so add this one onto that one, and you get 1.162. And S4, you get 1.178. S5, you get 1.1856. And then you just keep doing this forever. Now you think about this guy, let's get bigger. Let's get big pretty small. This guy actually converges, and we'll talk about that, in later lectures. But let me show you another one. What about if you have n equals 1 to infinity of just 1 over n? Well, that's equal to 1 plus a half plus a third plus a fourth plus a fifth plus, and you do that forever. Now there you got to have, so S1, that's 1. S2, that's going to be 1 plus a half, so it's 1 and a half. I can do that in my head. And then I got to do that plus that plus that, so that's 1 and a half plus a third, and 1 and a half plus a third in decimal, that's going to be 1.83 repeating. And then S4, I got to add that guy to it, and that gives you 2.083 repeating. S5 gives you 2.283 repeating. I'm going to do one more just so you don't think it's 3 repeating all the time. So S6 is 2.45. Now this one's growing, and it's growing pretty slow, but what's weird about this one, this guy actually diverges to infinity. This guy blows up to infinity. Okay, so that's strange. This guy converges, this guy diverges. This guy gets bigger and bigger and bigger and actually goes to infinity. This guy will actually approach a number. Okay. Now, when we start dealing with series, most of the time we can't figure out where they go exactly. What we're usually doing is just being happy with saying, yeah, this guy converges, or it doesn't converge. Find out where they go, sometimes that's just a little bit too hard for us to do. But here's one we actually can figure out where it goes. It's a geometric series. So you got the sum n equals 1 to infinity of a r to the n minus 1. And let's look at that one and let's see if we can figure out if this converges or not. Okay, so what would this be? Let's stick in n equals 1. So that's going to be a times r to the 0, but r to the 0 is going to be 1, so that's just a. And it's plus a times r to the 1. Sticking a 2, that's going to be a 1. A r squared plus a r cubed plus a r to the 4th plus, and just do that forever. So let's look at what would S n be in this case. So the first n terms in this guy, that would be a times 1, so it's going to be a plus a times r1 plus a times r squared plus, and where would we quit? We quit when we get to be n, so that's going to be n minus 1. So it's going to be a times r to the n minus 1. Okay, now let's take this guy right here and let's multiply it by r. What would S n times r be? That just means it takes all of these guys and multiply them by r. So that would be ar plus ar squared plus ar cubed plus dot 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 plus ar to the big N. Now what's S N minus R S N. That's gonna be, these guys are gonna be pluses, these guys are gonna be minuses. So if that's a plus and this is a minus, what's gonna happen to these two guys? They're gonna kill each other off. That one's gonna be a plus, this one's gonna be a minus, they're gonna kill each other off. Everybody's gonna kill each other off diagonally. The only people who will be left will be this guy and this guy. And now we can do a little algebra. That's Sn, so pull out an Sn, and what do you got? You got 1 minus r equals a plus a r to the n. Now divide by 1 minus r, and you're going to get Sn equals a plus a r to the n over 1 minus r. Now I was going to pull out an a out of that, and you're going to get a 1 plus r to the n over 1 minus r. Now, does this converge or not converge? That's what you got to ask yourself. So I'm going to erase this. I'll leave this part down here. A little harder working on one board, but I guess we'll manage. Okay, so we know that this thing, Sn, is equal to a 1 plus r to the n over 1 minus r. Now what's the limit as n goes to infinity of a 1 plus r to the n 1 minus r? Now if we can figure that guy out, that'll be where this goes, because as Sn goes to infinity, that's this guy going to infinity. Okay, so can we figure this out? Now, r is a constant, a is a constant, but as n gets bigger and bigger, this guy's always changing. What can you say about the limit as n goes to infinity of r to the n? What if r is less than 0? If r is, less than 1. What if r is less than 1? What's going to happen to this guy? Say like r is a half. If r is a half, that'll be a half times a half, which is a quarter, times half, which is an 8, times half, which is a 16, and a 32nd, and a 64, and a 128, and a 256, and a 512, 1024, and 1248, 496. So this guy is getting smaller and smaller and smaller, so this guy will go to 0. What if r equals 1? And what if r is bigger than 1? If r is equal to 1, you get a 0 on the bottom, so that doesn't make any sense. Can't use this guy. But go back to the original formula. You can have a times 1 to this power. That's just going to be a 1. So you have a plus a plus a. You add up enough a's, it will blow up sooner or later. If a is a half plus a half is 1, plus another half is 1.5, plus another is 2. So added up enough a's, this guy will blow up. So if r is equal to 1, this guy will go to infinity. Or if a is a negative, I'm going to go negative infinity. So this guy will diverge. Now what happens if r is bigger than 1? If r is bigger than 1, what happens to r to the n? Say you got 2. So 2 to the first power is 2, 2 to the second power is 4, and 8, and 16, what we did before. This guy's going to blow up, so this guy's going to diverge. Okay? Now, this actually works in absolute values. If r is a negative number, the same thing happens. So this thing right here converges. This guy goes to 0 if r in absolute values is less than 1. This guy will converge to a 1 over 1 minus r, because that will go to 0. If r is bigger than 1 in absolute values, if r is greater than or equal to 1, this guy will diverge. Okay. Let's do an example. Okay, erase this and we'll do an example. Let's look at the summation n equals 2 to infinity of a minus 5 to the n minus 1 over 6 to the n. Okay, what are we going to do with this guy? Now, I screwed this guy up a little bit. I didn't start with 1 like we did on the first one. Okay, and I'm going to show you a little bit of twist on this. First, we got to get these n's to match up. How am I going to do that? I'm going to pull out a 5. So let's say I want that to be n. So I'm going to multiply by a minus 5 over a minus 5. And then that's going to be a minus 5 to the n minus 1 over 6 to the n. Now look at that. That's going to be a summation n equals 2 to infinity. I'm going to put that minus 5 in here, so that's going to be a minus 5 to the n. Sorry. I got a 1 over a minus 5. I took that minus 5 in, so it's a minus 5 to the n over 6 to the n. So I'll rewrite that one more time, and I get a minus 1/5 summation n equals 2 to infinity of a minus 1/5 times a negative 5 over 6 to the n. Now, when you're doing these, if the ratio, the part that's raised to the n is smaller than 1 in absolute values, it will converge. And it'll converge to the first term. What's the first term? I'm going to stick in a 2. So when n equals 2, what are we going to get? A minus 1/5. Stick in a 2, that's going to be 25 over 36 times 1 over 1 minus r. Well, what's r? R is a minus 5/6. So that's the final answer. You should probably clean it up. So that'll be a negative, one of those are going to die, and you get 5, negative 5 over 36. And this is going to be 1 over 1 plus 5/6. So that's 6/6 plus 5/6, so it's 11/6. So you're going to get a minus 5/36, and you're going to get 11/6, so you're going to get 6/11. I didn't screw anything up. And that's why I don't like having people, I wish y'all were in class to keep me from screwing up on algebra. So it's going to be 6, so you get 11/6, flip it, so you get 6/11. The 6's will cancel with the 36, and you get a minus 5 over 6 times 11, so minus 5 over 66. Be your final answer on that guy. Okay. Sorry, I don't know if my writing's big enough for you to see. It's the first one. We'll work on it and try to get it better and better. Okay, so that should be enough, hopefully, for this first one. Let me give you some homework. I'm going to try to figure out a way for you to turn your homework in. I'll get back with you on that. So your homework, this is 11-2. So this will be a first assignment on 11-2. So 11-2A, I want you to do 1, 2, 6, 8, 16, 17, 20, 21, 23, and 25. Okay, I'll try to send that out in an email too. It's important to read your chapter because this is not the best way to get mathematics. I don't like doing stuff through videos. I like y'all have here so I can walk around and talk to you. but this is the best we can do, so make sure you read your book and do those problems, and we'll figure out what we're gonna do on homework in this next week. All right, thanks, bye, have a good day.